Okay, thanks for joining. Let's get started. So you have probably attended the keynote this morning where we announced OpenTelemetry. There was another panel discussion earlier today. If some of you attended that one, we're going to repeat the first section, which is a bit of the background and the introduction to OpenTelemetry. Sorry if you're going to have to go through that again. But after that, we're going to talk, we're going to give specifics about how the backwards compatibility with OpenTracing and OpenCensus is going to be achieved. So I'm going to do the first section. I'm going to try to actually maybe give some more background for the people who might have attended the previous session. And then Ben is going to talk about the compatibility with OpenTracing, and Bogdan is going to discuss the OpenCensus compatibility. I'm Spiros. I'm not Ben. Might look more like him now. I am the founder of Omnition, which is an observability company. We have been contributing to OpenCensus since almost the beginning. And specifically, we worked on the agent and collector service that can be used to collect traces and metrics. And we're going to be very involved in the new OpenTelemetry project as well. So let's start with the background. So OpenTelemetry essentially is a new project under CNCF. It's the outcome of the merger of OpenTracing and OpenCensus. But before we go into that, it's probably worth revisiting a bit what, I guess, telemetry is. So for most of us, telemetry today means really tracing metrics and logs. Typically, or in the world we live today, for most of us, these are collected separately and analyzed kind of separately, using different tools for both collection and analysis of these things. There's a lot of value in correlating these different artifacts together, but that has not been effectively done so far. Obviously, the goals of both OpenTracing and OpenCensus were to standardize a bit on some of these so that we can better correlate and collect all of this data. And to some extent, if we put effort as developers, let's say, to instrument our applications or to instrument open source frameworks, we should be able to use this data for whatever purpose we want with whatever backend we want. Traditionally, that has been quite difficult, but anyway, that's kind of the goal of the project, to make that very easy and very effective by being able to collect all these artifacts and correlate them using whatever backend of choice everyone has. Now, in addition to the different artifacts, effective, let's say, telemetry collection has to deal with a few different things, starting from instrumentation APIs. How do you instrument, especially shared libraries and frameworks for emitting this telemetry, implementation of those APIs, and those two have to be implemented separately for every language, and that's a lot of effort. And that's also why a project like this makes a lot of sense, because all of us can contribute together in making it happen. And also the data infrastructure for extracting this data from our application and transmitting it to whatever backends we might want to use for the analysis. And also there is orthogonal to all of that, really, ways in which, let's say, we achieve interoperability when, especially in a distributed application, when we're talking, when we're transferring this data across services, and the wide format that is used actually also for transmission of it. So it's a fairly broad area, and in the past, OpenTracing and OpenCensus had similar goals, but approached the problem in slightly different ways. So OpenTracing focused on tracing specifically, and tried to solve the API layer problem by being very focused. Support a lot of languages, had a lot of adoption, is already a project in CNCF. OpenCensus, on the other hand, tried to focus on actually more than one vertical, specifically tracing and metrics, and started working on logs recently. And also tried to focus on not just the API, but also the implementation and infrastructure for the collection of this data. And supported 5 languages, 5 primary languages, and a few others also. Also had broad adoption. The two approaches have some advantages, some disadvantages. I think when it comes to OpenTracing in particular, by focusing, I guess, just on tracing, it doesn't solve the full telemetry problem. So even if somebody were to instrument with OpenTracing, they would still have to use a different library or a different API for instrumenting for metrics and logs. OpenCensus tried to solve this by trying to do both at the same time and providing correlation, good correlation across them, but also probably had the coupling in OpenCensus was maybe too tight for certain use cases. It made it a bit difficult for developers, let's say, to choose only parts that they wanted to use for the product or the project, and also probably made it a bit more difficult for vendors and others who wanted to contribute or use parts of the ecosystem. Both of them were quite widely adopted and have a lot of contributors, a lot of users used in production, lots of actually components backing them both. Great, I guess, but that also had the problem that because there is an overlap and both of them were kind of successful, they gave the choice to, let's say, every open source framework in particular and library out there of having, or the choice was not necessarily a good thing because everyone who was deciding what to instrument their application with had to make a choice between the two, and it wasn't obvious which one is the best choice, given that there were some overlapping goals and success in both projects. So anyway, for all these reasons, I guess we decided to come together and merge these two projects into one. Both OpenTracing and OpenCensus are going to be replaced by OpenTelemetry. Maybe the best way to think about this is that OpenTelemetry is going to be the next major version of both projects, and we're going to provide full compatibility for any instrumentation that has been done with either project so far. And this is the primary goal of this talk, and we're going to talk about this in detail. And OpenCensus and OpenTracing will be around and will be supported for the next 2 years. But the projects are not going to be in active development after a few months when we fully move to OpenTelemetry. And with that background, I'll give you a few more details about what telemetry actually is, OpenTelemetry actually is, and then we'll go to the backwards compatibility section. So going back to this slide with the different verticals and different layers, OpenTracing and OpenCensus try to cover a few of these layers in different ways, but really, the entire thing is in the scope of OpenTelemetry. Initially, at least, we'll focus on tracing and metrics, and we'll cover, we'll cover the APIs, the implementations, and the data infrastructure, trying to become, let's say, the standard way of instrumenting cloud-native applications and collecting that data out of those applications. Looking at each one of these layers, so first of all, there is the Instrumentation API. We're going to create a new API that derives actually from OpenTracing and OpenCensus and is improved from some of the lessons from these projects. OpenCensus in particular had an API, but that was very tightly coupled with the implementation. So in OpenTelemetry, the APIs are separated, and there is a separate implementation for each one of them. And that tries to achieve context propagation, tracing and metrics, and correlation across those. And in the future, we're going to have an API for logs as well. The new API is going to have compatibility with both the existing instrumentation that has been done either with OpenTelemetry, OpenTracing, or OpenCensus via a bridge. And generally, the main goal of this is to rely on the existing adoption of these projects and broaden that so that hopefully in the future, all major open source frameworks and libraries are going to be instrumented with OpenTelemetry so that as application developers, we're going to be able to get that for free and not have to worry too much about it. As I mentioned, there are going to be canonical or, let's say, standard implementations for each one of these libraries for every major language. Hopefully that's what most of us will decide to use. And those libraries are going to try to use or rely on standards as much as possible. For example, we're using the W3C trace context propagation standard by default. That's already used in OpenCensus, and it's going to be used in OpenTelemetry as well. There is an open wire format for tracing. There's no standard for that yet, but we're going to be using an open wire format that others can adopt for tracing metrics and logs. And also, the implementation is vendor neutral, completely vendor neutral. By default, the client libraries will support exporters for popular open source backends like Jaeger, Zipkin for traces, Prometheus for metrics. But obviously, anybody can contribute any exporter they want for open source or a proprietary backend. One important thing to share here is that the client libraries are not starting from scratch completely. There is already an implementation for at least the popular languages that is coming from OpenCensus, and that has been used in production by many users. So it has already been hardened, and it's not a brand new implementation that will take a while to mature. Similarly, the project is going to inherit the agent and collector service from OpenCensus. That has also been around for a while and has been used in production by many users. The agent supports pretty much has exporters for all popular open source and commercial backends. There is naturally more flexibility in what you can include in the agent because it runs outside of the process. And it helps in quite a few ways achieve, let's say, better outcomes when you're trying to collect telemetry. For example, the agent can be deployed as a sidecar and can emit, let's say, or transmit the telemetry that's collected from the application, traces and metrics today, but also can collect infrastructure metrics, and all of these refer to the same objects, let's say, that generate this telemetry. So if your backend can utilize all of those, you should be able to correlate across all of them. Also, it has several other advantages. I'll give you a couple examples. Like for standalone applications that have already been instrumented, let's say, with OpenTelemetry, you don't even need to recompile them again. You can send that data to the agent, and from the agent, you can choose what backend to forward it to. In fact, you can forward it to more than one backend, or you can have different backends for metrics and tracing. The agent can also be deployed as a network service, and when you do that and you collect, let's say, in particular in the case of tracing, all your traces in one place, you can achieve other things or have like things like tail-based sampling done at that level. Also, the agent has receivers for really all the popular instrumentation kind of libraries. For example, you can have, let's say you have an existing application that has been instrumented with OpenTracing and is using the Jaeger client library. That can stay there, and the agent can accept that instrumentation. And let's say you have maybe some new services that have been instrumented with OpenTelemetry. The agent can merge all of that together and export full traces to the backend of your choice. And with that, we'll jump to the goals. But if you have any questions in the meantime, happy to answer.
So I understand the OpenTracing project and the OpenCensus project will not exist anymore in the future and will both be joined to OpenTelemetry. Did I got that?
Yes. So the idea is that OpenTelemetry is going to replace both projects, but any instrumentation that already exists or somebody is doing today will be, let's say, OpenTelemetry is going to offer backwards compatibility. Effectively, what's going to happen is these projects are going to stay around for at least a couple more years, but no new active development is going to happen in those after the next few months.
What will then be the trade-off? I understand why OpenTracing was focusing on many languages or lots of languages to speaking telling from your slides, while OpenCensus is only supporting a few languages. what will be the trade-off? Will you say, okay, now we're supporting all the languages that OpenTracing was supporting, or are you going to strip it down to what OpenCensus supports?
I can speak a bit about OpenCensus. The goal was not to support fewer languages. It was just that, let's say, the mature languages were fewer than the case of OpenTracing because, I mean, there is an actual implementation. It's a bit more work to do that. So I think going forward, the goal is to support all the popular languages. I think the roadmap has 9 languages that are going to be available. Yes. But thank you. Ben?
Yeah, thanks a lot. And one other thing I would add is that when we talk about OpenTracing or OpenCensus code, there's the code in the core project itself, and then there's all of the instrumentation that's in the world. The code in the core project will be kind of put into read-only mode, ideally by the end of this calendar year, and we expect that there will still be additional instrumentation being written for some period of time until people have migrated over. So it's important to draw the distinction between instrumentation code and then the core code. I think the core code is the stuff that we'd like to stop adding additional features to by the end of the year. The elephant in the room for this project is absolutely the fact that, you know, there's the XKCD comic where you have 14 standards and you want to create a single unified way to access them, and so you create a 15th standard. That's what we're trying to avoid. The people working on OpenTelemetry have a lot of history in this space, and I think we wanted to create a totally greenfield, fresh start, and we resisted that temptation, and the goal for 2019 is really strictly focused on backwards compatibility and making a clean migration path for people who are presently using OpenTracing or OpenCensus. Until we've accomplished that, I don't think we'll pursue any kind of new feature work at all. We're really very focused on consolidating. Hopefully this will this slide is some sort of formatting issue, but we'd expect that by September we have what we would call parity across all the languages that are supported by OpenTracing and OpenCensus right now. Some of those languages are more mature than others, so I think getting to parity for a language that doesn't have a mature implementation is easier than getting to parity for, say, Java or Python, where there's a much more mature ecosystem around it. Like, for instance, there's an OpenTracing library in Rust that's actually very young. And getting to parity with that will be pretty easy because it's just getting started. And then by November, we'd like both OpenTracing and OpenCensus to be in this kind of read-only mode where we're not making changes to the core of the projects anymore, but we're still supporting them for 2 years after that date. The long-term project, of course, long-term goal is to have one project and to have this broad surface area and loose coupling. I also want to mention the governance structure for OpenTelemetry has been modeled pretty explicitly after the Kubernetes governance. We have 9 seats in the governing committee. There are limitations on how many seats can be occupied by a single vendor or project. There are limitations on how long someone can be in one of those seats, et cetera, which should allow for the project to maintain the common interests of the end users and won't be dominated by any particular vendor or swayed in that way, which I think is also like a nice thing that we had sort of informally in OpenTracing and OpenCensus, but it wasn't as explicit. It's going to be very difficult in OpenTelemetry to do anything but like operate in a truly kind of portable cross-vendor way, just based on the governance structure. Oh yeah, I just ruined these slides by saying it. You can look this up online if you want on the OpenTelemetry GitHub, if you want to look at how community membership works and how governance works, but there are 3 levels of membership as contributors to the core project. Anyone here is welcome to become a contributor. It'd be great to have more people involved. We're trying to do a lot of work very quickly, and it's unusual to be able to join a project that's going to move this quickly at this stage, and it should be pretty fun, especially if you are familiar with a language that's not Java, Python, or Go, where we have a lot of depth. There's a lot of work to be done, and it would be great to have more hands on deck. So this is kind of an advertisement as well. The governance, I already referred to this a little bit. We won't have any benevolent dictators in this project. It's going to, there are staggered elections, and people will be flowing through the governance relatively quickly. And I think that it should serve the long-term interests of this entire ecosystem well. So I think that was sort of formally the end of this overview. The next thing is backwards compatibility by OpenTracing. But I will just, I guess Spiros took a few questions. Are there any questions about just what you've seen so far, aside from compatibility, which we'll address in much more detail? Okay, cool. So let's talk about backwards compatibility with OpenTracing. First, this show of hands, who here is like either using or is using OpenTracing in some capacity? Okay, great. So I wrote these slides with the intention of being clear, but if this is not clear enough, just ask questions or whatever. Here's this slide again. OpenTracing's footprint is tracing APIs, and so it's kind of right there. The rest of it, there are things in OpenTracing that touch on other pieces of this. There are people who've written, an open-sourced implementations of OpenTracing, formats, et cetera, but the core of the project is really very narrowly restricted to this. So part of the effort here is to broaden the surface area. The broadening is easy in that we're just adding more things, and that doesn't create any compatibility issues. The compatibility discussion is really focused on things in this slice of the matrix, because this is where OpenTracing has been so focused. The best place to start is probably this slide, which is taken totally unmodified from a presentation last year that a friend of mine did on OpenTracing. So the basic concepts, of course, you have the full transaction trace, which goes across services. It's composed of spans, which are these timed segments. Typically, you have at least one span per RPC call, and then hopefully a few more to help explain aspects of a request that can greatly affect the critical path. You have the SpanContext, which has trace identifier, span identifier, and some other stuff in it. OpenTracing did relatively recently add trace ID and span ID as formal parts of OpenTracing, but not nearly to the level of detail that OpenCensus or OpenTelemetry do, adopting the W3C spec that's just kind of coming to maturity around now. I wanted to address where there are changes in OpenTracing. Again, there's a compatibility bridge. If you speak Java, you can look at it right now. Is Carlos here? I don't see him. Carlos Alberto wrote a bridge from OpenTracing, an OpenTracing tracer to OpenTelemetry, and you can look at how all this stuff is being addressed. But there are some interesting changes between the OpenTracing API and the tracing API from OpenTelemetry. So here they are. So the OpenTelemetry SpanContext, which is the class that's responsible for reifying the trace ID and the span ID, sampled bits, that sort of stuff. It's highly non-abstract. So in OpenTracing, it was a pure interface. In OpenTelemetry in Java, for instance, it's a final class. Like, you literally can't extend it. And so we have a much more opinionated stance about the sorts of trace and span IDs that we expect people to have. I was responsible for the design of the original OpenTracing API, and I wanted to remain open to other models. Those models just have not appeared in production. I think everyone's using tracing systems or APMs that have something like a span, so this model has been sufficient. I think in a few years or something like that down the line, you can imagine something more general happening, but it's not happening now. So, so the SpanContext is much more concrete. This actually has a lot of benefits in that you can, if you want to integrate with a logging system or something, you can be guaranteed that any OpenTelemetry implementation has to provide a trace ID and has to provide a span ID. This has been a feature request in OpenTracing really since the dawn of time for OpenTracing, and that will now be a trivial thing and doesn't involve any kind of weird class cast exceptions that you have to worry about or anything like that. It's just part of the interface. The baggage feature in OpenTracing, that's a key value pair that propagates with the request. That's still, there's an analogous concept in the W3C trace context called correlation context, and so you can still do something similar, but it's not called baggage anymore. You also see a more robust treatment of propagation of a context within a process. This just necessarily varies by language. Like in Go, there's the Go context, which is just part of the idiom of programming in Go. In Java, you have a much more heterogeneous way of dealing with it, but in every language, we want to have a clear runtime answer to context propagation for OpenTelemetry users. And so what that means in plain English is that statically, you should always be able to access the current distributed context. You shouldn't have to do anything funny to get the distributed context. It's either going to be a local variable, or you can access it via a thread local or whatever is appropriate for the language. Also, OpenTracing did support like a standard string representation of whether there is sampling or not, but it didn't have special methods around whether the current request is sampled or not sampled. OpenTelemetry's SpanContext does put that on the SpanContext. I mention this because it's an important optimization for many people. If you're not in a sampled trace, you can avoid extra work to create tag values and things like that. So that's something that we've also added to the OpenTelemetry side. For the span itself, so this is the thing that has a start time and end time and a bunch of key value pairs and time-stamped key value pairs on it. There are a bunch of naming changes. So in OpenTracing, we call them tags. In OpenTelemetry, we call them attributes. In OpenTracing, we call them quote-unquote logs, which generated a huge amount of fury, and I regret that choice of names. So in order to avoid the fury, this time we're calling it events. But conceptually, they're very, very similar. OpenTracing had a notion of references, which is a way of saying that this span descended from another span, which was its parent. Conceptually, what we're doing in OpenTelemetry is very similar, but not exactly the same. And you can look at the API if you want yourself in Java for an example of how this will work. But there's a notion that every span has 0 or 1 parents. If you have 1 parent, you can say what kind of parent it is by talking about client relationships, server relationships, and then for things like Kafka, et cetera, there's a notion of a producer and a consumer. This will allow for downstream UIs and analytical tools to correctly analyze the kind of causal relationships between the different spans. So in that sense, it's very similar to references. There's something that was not in OpenTracing at all, which we've added from OpenCensus, which is the idea of a linked span. So the idea is if you have, let's say you're writing some kind of shared service that has to batch requests and then write them off to some database, all of the batched requests in a single batch have a shared fate in terms of latency. So if you make 100 requests and they all get batched, and then that write to your database takes a long time, all 100 requests will be slow. And the members of the batch have a relationship with each other. It's important to have that represented in the tracing somehow so that you can figure out what went on. OpenTelemetry has this idea of a linked span, which can be used for many things, but I think the usual use case we talk about is batching and other forms of aggregation between different transactions. So that is now part of the OpenTelemetry API. OpenTracing allows for the explicit set of start and finish time on a span. This was usually used to take data that came from some offline source and then kind of transcode it into OpenTracing. We're assuming in OpenTelemetry that people would rather just transcode directly to the common formats that OpenTelemetry has. And so for that reason, we're going to only add these APIs if there's a demonstrated user need for them, because obviously all things being equal, a smaller API is a better API. It's not a terribly difficult thing to support, but we don't want to create that surface area when we think the use case would be better served by directly consuming the data formats of OpenTelemetry. I'm realizing when I'm doing this talk, this is like incredibly dense. I don't know how anyone's paying attention to this and absorbing any of it. Are there questions on this slide or the previous one, just to take them in kind? People are either lying or very smart, probably very smart. Okay. I'm impressed. I'm really impressed. And then for the tracer itself, it's not that different. They both provide access to the current span. The language changes a little bit. It's actually easier in OpenTelemetry than it was in OpenTracing. And there's also this really cool concept of a resource. So this is the idea that you want to say, basically, TLDR, this tracer is part of this process, and this process uses a certain amount of CPU and memory. We'd like to be able to get that data, and in the earlier session this morning, someone was asking a great question about how we're going to do correlations between different streams of metrics and traces and stuff. This resource idea is really important there, where it's going to be possible in a portable way to say that the CPU and memory from your process will be easy to it'll be easy to reflect that in the traces, regardless of which vendor you use for tracing. I think that's really important in that a lot of latency issues and reliability issues have to do with the resource itself being overloaded. And I think that this will make it much easier to spot that sort of thing. And as a kind of minor thing, we had this idea of closing a tracer in OpenTelemetry. I don't think that, we kind of regret adding that to the API. We'll keep a flush, which is important for for testing, but I think we'll probably get rid of the close, which was only being used for testing anyway. So just to dig into Java a little bit, I tried not to talk too much about Java, but Java is where we're doing the prototyping. I think we feel like that's the most robust community for both OpenTracing and OpenCensus, and probably in enterprise in general. And so we want to make sure that that's the place that we use we want to get all the compatibility working there first. You definitely should look at this if you want, especially if you speak OpenTracing. You can go and look at the Shim that we've written and verify that it actually meets your requirements and everything. I think it will. But the guts of it is the following. So the way that the compatibility will really work for OpenTracing users, and of course this isn't written in Java, but the same thing will be true for other languages. You presently have some line of code where you're installing an OpenTracing tracer, which is this thing up here in your application. So what you'll be doing is replacing that with this tracer shim that itself takes an OpenTelemetry tracer as an argument. If you add this in replacement of your OpenTracing initialization, you'll be able to mix OpenTracing, OpenCensus, and OpenTelemetry instrumentation in your single Java process, and it will all just work. We'll be doing similar things with other languages. This is basically, we said in the keynote, I think, that we think of OpenTelemetry as the next major version of OpenTracing. That's really true. We had a major version, well, I guess technically it wasn't because we're still in the 0. Release chain, but we had a breaking change in OpenTracing about a year ago, and we released a similar shim to do that, and it worked well. So we're treating this the same way. This is really a version upgrade for OpenTracing, where we're getting a bunch of improvements, and we'll use this sort of shim approach. But it's nice because this is the only code change you'll have to make, assuming you believe everything else I'm saying, and that's the way that we've been designing these APIs. And for what it's worth, we won't qualify an OpenTelemetry API until we're able to make this work in any language. It's part of the requirement for the OpenTelemetry APIs. Other languages, our immediate priorities are written on this slide. We're expecting to have something that you can validate by September. I think I wrote the slide on an airplane. That doesn't make any sense. Already working on several begins soon. I don't know what that means, but we're starting many of these soon. So that's probably what I meant. We're also, I think this is addressing your question earlier about language support. So this set of languages is supported in OpenTracing with the possible exception of straight C, which the use for that, I think, was almost always something that would have been better suited by just writing raw data. But with the rest of these, we expect to, basically go through the steps that are on this slide. One thing I would mention about OpenCensus is that they've made an effort to write really high throughput, high quality implementations of the API in OpenCensus. We want to write correct reference implementations as soon as we can for these languages. I think it'll be interesting for us to figure out, we have this slide we keep on showing of, the one with the matrix of rows and columns. It's probably the case that we'll end up at a mature place with the API slightly before we have a mature performant implementation. And when people will choose to adopt these things is a little bit TBD. I think if you want to wait until the reference implementation is there, that will probably extend through into November or December for a lot of these languages. But the OpenTracing part, which is just the API, should be ready earlier. All we really want to do is verify that we will be able to provide a high-quality reference implementation, and we can get there once we've gotten this simple correct version done. So yeah, none of these things will be considered done until we have demonstrated evidence we'll be able to create a correct bridge from OpenTracing and OpenCensus. And this is obviously a huge amount of work. But there are a number of different parties that are all pretty interested in seeing this happen quickly, and we're trying to minimize the amount of time where there's an ambiguity about where you should write your instrumentation. And we want to get all that into OpenTelemetry by the end of the year. I just wanted to say, in terms of the philosophical alignment, I did a lot of talks about OpenTracing, and my biggest regret about it, I was kind of right, but then I didn't take my own advice, was that the instrumentation should describe the software, not where it's going. And the trouble is that we didn't do that with OpenTracing. Like, if you have a request, all you should be saying is like, I just had a request, it took this long. It shouldn't be a tracing API, it should just say that happened. And then if you want to use that for metrics or logs, you should be able to do that too. And I think one of the complaints we had with OpenTracing was that people were adding OpenTracing instrumentation and then also adding, I don't know, Prometheus instrumentation, and also putting stuff into ELK. This approach should actually get closer to the philosophical orientation that we had for OpenTracing originally, which is that you just describe your software and then the telemetry data flows out of that. So this is actually, ironically, the OpenTelemetry charter is probably closer to the philosophy we were trying to espouse with OpenTracing than OpenTracing is. But you know, you always get a second chance or something. Yeah, so you know, we'll be broadening what you can get. It'll be great. And I'm done. So any questions about the OpenTracing part? Quiet crowd. I don't believe it. Yes?
It's not specific to OpenTracing, but to Telemetry more generally. We have a lot of trouble indicating which metric information, tracing information, telemetry information is safe to remove, export, and move between different environments. So we have certain production environments, certain other environments, and so on. So we came up with ideas to basically tag subsets of this information to indicate to the transport systems that take those signals and move them between environments, which parts of the information will stay where they were produced and which ones are actually okay to move away. Is this something you're considering?
That's a really good question. I like the thought process behind it. So just to summarize for the recording, do we plan to add some kind of convention whereby people can tag where the data is going to be used, and also kind of for how long, I guess, like when you can remove it, that sort of thing? Is that the idea?
Yeah, I mean, to give a concrete example, so whenever a system, maybe the basic difference between user-supplied data, which might be unsafe to move to a telemetry system because maybe the user accidentally pasted in the password, and that's probably not something you want to ship to the telemetry system just because you have a log line that emitted this piece of information after some in a stack trace, let's say, versus information that is sort of nobly safe because it's a constant in your source code, and we know that this is safe information that you can transfer wherever you want because it's never user data. So the dichotomy between these two is something that we struggle to, we had to implement, and we didn't find this anyway.
That's a good question. When I worked at Google, we had a compilation error if you didn't add a human-readable description of what a given metric actually was for. I like the idea of also adding an expiration date. Like, if you don't re-up this thing, it's by default removable or something like that. To be honest, though, we haven't actually created those sorts of requirements at the compilation level for OpenTracing or OpenCensus, and I don't think we've talked about it for OpenTelemetry, but I definitely understand where you're coming from. I think there are a lot of pieces of telemetry data that are out there in the world, and no one knows if someone needs them or who needs them, but no one feels comfortable deleting them. We actually did do a study when I was at Google where we analyzed their long-term time series store to see which data was being accessed by an actual human being. So you could tell if the reader was like a MapReduce or an actual human being. And they found, I'm going to get the number wrong, but it was like way under 0.1% of the data was ever read by a person ever. And so they're like, oh, this is very sensible. We'll just make a policy that after a month, we'll just delete it, unless it's in this whitelist. And people freaked out, like absolutely freaked out, because how could you ever delete this data? What if we need it sometime? So people do feel a lot of anxiety about removing telemetry. It's a good, you should join some of the discussions. It would be great to think of a way just to at least annotate the intention behind the data. Yeah. Other questions? Or I'm going to get off the stage. Okay, great. Spiros, I think you're up. Oh, no, Bogdan, you're up. Cool. Thanks.
Yeah, I'm going to present from the OpenCensus perspective what we're going to do for backwards compatibility and how we would support our current users. What we will do is going to be a bit different than OpenTracing. We probably are going to do a more aggressive transition of our users. Main reason being the fact that we have a pretty large code base, not necessary for instrumentation, but because of the implementations and all the exporters that we support. And being in a state where we have duplicated code for us will be kind of unacceptable. That means a lot of work for us to fix bugs in 2 different places. So we'll probably be a bit more aggressive on moving our users from the old project to the new one. There are clearly some differences between OpenTelemetry and OpenCensus. The main one being the fact that we learn from OpenTracing that having a clear API is very important, and having this separation between API and implementation helps a lot of the vendors and a lot of the parties to trust more the project. One of the code that I remember from Amazon X-Ray was like, what if Google starts to go crazy with their implementation, and we want to have our own implementation and just move forward just with only the API. And I think it's very important that we offer this ability for others to completely re-implement the API if they want. But I also believe that having a standard implementation in place is the right thing to do. The API change, comparing with OpenCensus, we have done limited number of changes, not too many, but there are still breaking changes, especially the fact that the package name changed. The implementation of the OpenTelemetry library will be mostly based on the OpenCensus. That's because of a obvious fact that there were no standard implementation for OpenTracing, so we decided, like, if we already have one, let's change that and modify it to be here. We will also, at one point, start porting our agent collector infrastructure. These are very useful, especially for precompiled binaries, like HBase, Envoy. For example, instead of them choosing the vendor for you, they will just say, we'll push the data to a sidecar, deploy the sidecar with whatever format you want to use or whatever backend you want to use. For the OpenCensus library, what we plan to do is actually changing so first we want to get to OpenTelemetry alpha release. After we have an alpha release, what we will plan to do is immediately change all our public APIs to forward everything to the new project, which means we will delete most of the code from OpenCensus as part of this transition point. That means that what the OpenCensus will become just a simple Shim that forwards all the calls between the public OpenCensus API and OpenTelemetry. this is very important because this will also make the OpenTelemetry implementation being used. And so every bug or every problem that we have only to fix that into OpenTelemetry, and we no longer have to deal with a lot of OpenCensus problems. Then probably users, at one point users will have to start transition their code, their API calls. Instead of calling the OpenCensus public APIs, they will start migrating to the new library. We are very careful with this step, and we literally want to avoid having our users to do a big PR and change everything in one PR, because that's almost impossible. So we will enforce that you can have a binary that works with OpenTracing, OpenCensus, and OpenTelemetry in the same time. That will give us enough time for this transition to happen slowly and with the right piece that we need. And the last part will be end of the life for OpenCensus and partying that we achieved the transition for this project. For the agent thing, what we would like to do is we have this sidecar or agent implementation that supports multiple receivers and also exporters. What we'll do, first thing, we'll just probably rename the binaries. Then we'll have to add support for the new protocol, for the new OpenTelemetry data format, which changed from OpenCensus. And in this, after the upgrade of the sidecar, you will be able to slowly start changing new projects to use the new protocol. That will, this will be for incoming traffic and outgoing traffic as well. And after a couple of upgrades, probably we'll end up removing the OpenCensus protocol, which will be probably in 2 years, I think. We promised 2 years backwards compatibility for everything. And that's almost what we plan to do for OpenCensus. Questions? Between OpenCensus and OpenTelemetry? Yeah, sorry. There are a couple of things. People didn't like the fact that we have this event, different type of events, so we generalize under one event, so we had to change that into the data model. I think that's almost I think that's the single breaking change that we have. So implementation-wise, it's going to be just a copy-paste of the other implementation, but we still have to, and is because we use gRPC, the namespace is backwards incompatible. Like in a stubby or gRPC, changing the namespace will be backwards incompatible for us. That's another thing that we need to have.